Ground fault current interrupter protection is required for all 120 volts, 15 amps and 20 amps receptacles in bathrooms, kitchens, garages, crawl spaces, basements, laundry areas, and within 6 feet of a sink in outdoor locations. Ground fault current interrupter protection is not required for 120 volts, 15 amps and 20 amps receptacles in industrial plants. However, ground fault current interrupter protection is required for all 15 amps and 20 amps, 125 volts receptacles installed in accordance with Section 590.6 of the National Electrical Code, which includes receptacles installed in crawl spaces, basements, utility rooms, workshops, and garages. Ground fault current interrupter protection is required for all 120 volts, 15 amps and 20 amps receptacles installed outdoors. Ground fault current interrupter protection is not required for 120 volts, 15 amps and 20 amps receptacles installed in bathrooms if the receptacle is part of a lighting fixture or is located more than 6 feet from a sink. Now, let's break down these requirements further. Firstly, the core principle behind ground fault current interrupter protection is safety. It's designed to protect individuals from electrical shock by detecting ground faults, which occur when current leaks from its intended path to ground. This leakage can happen due to damaged insulation, faulty wiring, or even moisture. When a ground fault is detected, the ground fault current interrupter trips, quickly cutting off the power and preventing a potentially fatal shock. Secondly, the specific locations mentioned in the requirements are areas where the risk of electric shock is high due to the presence of water or moisture. Bathrooms, kitchens, laundry areas, and outdoor locations are prime examples. Water is an excellent conductor of electricity, so any electrical fault in these areas poses a significant hazard. For instance, a faulty appliance in a wet bathroom could easily cause a ground fault, potentially electrocuting someone. Thirdly, the exception for industrial plants might seem counterintuitive at first. However, industrial environments often have comprehensive safety programs and trained personnel who are equipped to handle electrical hazards. Additionally, the equipment used in industrial settings is often designed with specific safety features that minimize the risk of ground faults. It is crucial to remember that even though ground fault current interrupter protection may not be explicitly required in industrial plants, it is still a good practice to implement it whenever possible. Fourthly, the reference to National Electrical Code Section 590.6 highlights the importance of temporary electrical power during construction, remodeling, or demolition. This section mandates ground fault current interrupter protection for all 15 amps and 20 amps, 125 volts receptacles used in these temporary setups. This is because temporary wiring is often more susceptible to damage and environmental factors, increasing the risk of ground faults. Fifthly, the exception for receptacles located more than 6 feet from a sink in bathrooms acknowledges that the risk of water exposure decreases with distance. While it is still possible for a ground fault to occur, the likelihood is significantly lower compared to receptacles directly adjacent to a sink. Sixthly, it's important to distinguish between different types of receptacles. The requirements specifically mention 15 amps and 20 amps receptacles. These are the most common types of receptacles found in residential and commercial settings. However, larger amperage receptacles, such as those used for heavy-duty appliances or machinery, may not be subject to the same ground fault current interrupter protection requirements. Seventhly, ground fault current interrupters work by constantly monitoring the current flowing through the hot and neutral wires of a circuit. In a normal circuit, the current flowing through both wires should be equal. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance. The ground fault current interrupter detects this imbalance and quickly trips, usually within a fraction of a second. Eighthly, it's essential to test ground fault current interrupters regularly to ensure they are functioning properly. Most ground fault current interrupters have a test button that simulates a ground fault. When the test button is pressed, the ground fault current interrupter should trip, cutting off the power to the circuit. If the ground fault current interrupter does not trip, it should be replaced immediately. Ninthly, ground fault current interrupters are not a substitute for proper wiring and grounding. They are an additional layer of protection that should be used in conjunction with other safety measures. Proper wiring and grounding help to prevent ground faults from occurring in the first place, while ground fault current interrupters provide protection in case a ground fault does occur. Tenthly, it's important to consult the latest edition of the National Electrical Code for the most up-to-date information on ground fault current interrupter protection requirements. The National Electrical Code is a comprehensive set of standards for electrical safety, and it is regularly updated to reflect new technologies and best practices. Now let's elaborate further on the practical implications of these regulations. Consider a typical residential setting. The kitchen is a prime example of an area where ground fault current interrupter protection is essential. With multiple appliances such as refrigerators, dishwashers, and microwave ovens all operating in close proximity to water sources, the risk of electrical shock is significant. Therefore, all 15 amps and 20 amps receptacles serving countertop areas in the kitchen must be ground fault current interrupter protected. Similarly, bathrooms pose a significant risk due to the presence of sinks, showers, and bathtubs. All receptacles in bathrooms, with the exception of those that are part of a lighting fixture or located more than 6 feet from a sink, must be ground fault current interrupter protected. This includes receptacles used for hair dryers, electric shavers, and other personal care appliances. Garages are another area where ground fault current interrupter protection is crucial. Garages are often used for a variety of tasks, including car repairs, woodworking, and other activities that involve the use of powered tools. These tools can be particularly hazardous in wet or damp conditions, making ground fault current interrupter protection essential for all 15 amps and 20 amps receptacles in the garage. Basements and crawl spaces are also prone to moisture and dampness, increasing the risk of electrical shock. Therefore, all 15 amps and 20 amps receptacles in these areas must be ground fault current interrupter protected. This includes receptacles used for sump pumps, washing machines, and other appliances. Outdoor locations present a unique set of challenges due to exposure to the elements. Rain, snow, and humidity can all increase the risk of electrical shock. Therefore, all 15 amps and 20 amps receptacles installed outdoors must be ground fault current interrupter protected. This includes receptacles used for outdoor lighting, power tools, and other equipment. Now let's turn our attention to industrial plants. As mentioned earlier, ground fault current interrupter protection is generally not required for 120 volts, 15 amps and 20 amps receptacles in industrial plants. This exception is based on the assumption that industrial plants have comprehensive safety programs and trained personnel who are equipped to handle electrical hazards. However, it is important to note that this exception is not absolute. In certain situations, ground fault current interrupter protection may be required in industrial plants. For example, if a receptacle is located in a wet or damp area, or if it is used to power equipment that is likely to be exposed to moisture, ground fault current interrupter protection may be required. Furthermore, many industrial plants choose to implement ground fault current interrupter protection voluntarily, even when it is not required by code. This is because ground fault current interrupter protection provides an additional layer of safety that can help to prevent electrical shocks and injuries. Now, let's consider the specific case of sump pumps and water fountains. Sump pumps are commonly used in basements and crawl spaces to remove excess water. Because these areas are often damp or wet, the risk of electrical shock is significant. Therefore, it is generally recommended that sump pumps be connected to ground fault current interrupter protected receptacles. Water fountains, on the other hand, present a slightly different set of challenges. Water fountains are typically located in public areas where they are accessible to a wide range of people, including children. This increases the risk of accidental contact with electrical components. Therefore, it is generally recommended that water fountains be connected to ground fault current interrupter protected receptacles. In summary, ground fault current interrupter protection is a critical safety measure that can help to prevent electrical shocks and injuries. While the specific requirements for ground fault current interrupter protection vary depending on the location and application, the basic principle remains the same: protect people from the dangers of electricity. By understanding the requirements for ground fault current interrupter protection and implementing them correctly, we can create a safer environment for ourselves and others. It's also worth noting that local jurisdictions may have additional requirements for ground fault current interrupter protection beyond those specified in the National Electrical Code. Therefore, it is always important to check with your local building department or electrical inspector to ensure that you are in compliance with all applicable regulations. In addition to ground fault current interrupters, there are other types of ground fault protection devices available. Ground fault equipment protection, or GFEP, is designed to protect equipment from damage due to ground faults. Ground fault equipment protection devices typically trip at a higher current level than ground fault current interrupters, and they are not intended to protect people from electrical shock. Arc fault circuit interrupters, or RFCIs, are designed to protect against fires caused by arc faults. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc. Arc fault circuit interrupters detect these arcs and quickly trip, preventing a fire from starting. It is important to choose the right type of ground fault protection device for your specific application. Ground fault current interrupters are the best choice for protecting people from electrical shock, while ground fault equipment protection devices are the best choice for protecting equipment from damage. Arc fault circuit interrupters are the best choice for protecting against fires caused by arc faults. When installing ground fault current interrupters, it is important to follow the manufacturer's instructions carefully. Ground fault current interrupters should be installed by a qualified electrician. Before working on any electrical wiring, always disconnect the power at the main breaker. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical wiring in wet or damp conditions. If you are not comfortable working on electrical wiring, hire a qualified electrician. Regular inspection and maintenance of electrical systems are essential for ensuring safety. Inspect wiring for damage or wear. Replace damaged or worn wiring immediately. Test ground fault current interrupters regularly to ensure they are functioning properly. Keep electrical panels and equipment clean and dry. Do not overload electrical circuits. Use extension cords sparingly and only for temporary purposes. Do not run extension cords under rugs or furniture. Keep flammable materials away from electrical equipment. In conclusion, ground fault current interrupter protection is a vital safety measure that can help to prevent electrical shocks and injuries. By understanding the requirements for ground fault current interrupter protection and implementing them correctly, we can create a safer environment for ourselves and others. Remember to consult the latest edition of the National Electrical Code in your local building department for the most up-to-date information and requirements. Always prioritize safety when working with electricity. Ground fault current interrupters are a critical component of a safe electrical system, but they are not a substitute for common sense and safe work practices. Always exercise caution when working with electricity, and never take risks that could jeopardize your safety or the safety of others.